Welcome back everyone. After the practical, I hope that you have actually enjoyed the lesson and the sequence that we are going to working on that. Well, let's see that what are the sequence. Well, as the name suggests, sequence is a series, and in the sequence we have three things basically: string, lists and tuple. Let's proceed with the string and you will go to know that what exactly the sequence means. Well, strings are just the alphabets such as name. Well, like just print Udemy and it will going to print Udemy as the output. So our output is Udemy. It's that simple, right? Now, the second one is the list. So what is a list? Well, first of all, we are using the square bracket, so you should have to put care for the bracket sometimes, and we are going to create the list. So this is the list. Well, what this thing is doing here? Well, when the Python was invented, there was nothing called as spacebar. Well, there is, but to interpret that, there was not much thing. So we are using this, and you have to remember that Python was invented in 1980s and first public release was in 1991. So it's not quite so much new, like, right? So we need to use something to define the space sometimes. So that's it. That's pretty much it. Let's proceed. So 1, 2, 3. This is our list. Well, you can have the list of the items just like the set, but there is a slight difference. Obviously, you are packing up the item in a different way. Which way? Well, we are going to see that. Just wait for a while. Now the tuples. So tuples are immutable sequences. What is immutable? Well, you cannot disturb its item, means you cannot delete it, you cannot write or overwrite it, you cannot perform any operation actually on the tuples, which is actually good. Just like the constitution of a country, you cannot touch the fundamental rights and duties. The same happens with the tuple. You cannot touch the very fundamental of the code. Like even in the open source coding, we cannot touch the very fundamentals of that particular code. We can create a new one, but we cannot change the basic of it. That's the immutable means, which is actually good to maintain its real identity, which is it's based upon. Well, that's pretty much it. That's why these things are called in sequence. And why the sequence? Now let me justify that one too. Well, it is called as sequence because we can use the indexing to call a particular number that we are going to see in the program. Welcome back everyone. Now we are going to see the data types. As you have already learned some data types, and we are going to work on the numeric one first, and in the numeric one we are going to work with the integers. So before we are jumping on the integer, let me teach you something, that how you can write the comments. Well, there's a separate lesson for that too in the course, but I'm going to teach you here as in the practical world, because we are going to read and use that quite often. So to put the comment, you just put the hash and you can write anything you want, like we are working with numerics. That's a data type. No matter the way I'm writing it, if I run this, you will see nothing. As you can see, it's unchanged. I can hit run again. It's not changing. So why it's not changing? It's not changing because of a very simple reason. The comment, whenever you put the hash in the Python program, in the compiler or interpreter, whatever you would like to call it, it will not going to get translated, because that's for us, for humans, to understand the codes well and understand that what we are going to do, like we are going to work with the numeric data type. So let's start working with integers. So to add up with the integers, I would like to just start with the very simple thing, and I would like to tell you first what are integers. So integers are basically negative, 0 or positive numbers. That's it. That's completely it. That is what integer actually means, exactly as in mathematics it do. Now let's try that. Let's initialize our values like x. X is a variable here. I will going to explain that in a bit. Let's just write 2 plus 5 and let's try to hit enter, and let's see that what if we do not put the print command. Is it going to give us any answer or anything or not? So as you can see, nothing has happened here. So why it is so? It is not even an error because compiler know its answer, but you're not asking, you are saying to keep that. So it is saved. Like let's just print this now. So we have print x. Now let's just hit run. And you can see the answer. It's 7. 5 plus 2 is 7. So unless you are going to say Python that please print me the answer, which is x, till that time it will not going to print anything. It will not going to show you any kind of the error because you are not asking the answer, but still you are keeping something. Maybe for the later purpose. That's what Python thinks. So let me tell you what we have used here. So let's read a comment. Well, x is a variable. We are going to discuss the variable later in our course, but for now I have to tell you what is variable. Otherwise, why we are keeping it? Why not just 2 plus 5? But if we put just 2 plus 5, you can just simply imagine what can I call Python to print? I cannot call it to print 7. That's the answer itself. I want Python to solve this simple problem 2 plus 5 for me. That includes x as a variable, which is actually the memory, the space which is occupied. And first time the 2 gets in, the second operand is 5, and we are using the operator as positive or addition, and then the operation is going to happen in the arithmetic circuit behind the scene. I teach the electronics, so you can trust me that this thing happen in the background. So x is a variable, equals to is just to initialize the thing. 2 plus 5 are the numbers or the operands. Positive sign is the operator, which is addition. That's pretty much all. So you just have learned how the integers actually work. So now let's just try something else. After the integer, let's try something different, which is complex number. So let's try complex numbers. So what are the complex numbers? Well, complex numbers are basically the real number with the imaginary number. Let me mention it here so that you can learn that. Complex numbers have two parts. First is the real part and second is imaginary part. Well, if you have studied that in the high school mathematics, you surely have gone through these things, like I is the iota, and we are going to use that kind of things for the complex number, which is going to be used in so many kind of the calculation and applications in the economics and pure mathematics many times. Often I is the thing or the game of the thing, which is actually found by Euler. And that changed the entire, actually everything about the numbers and our thinking about the complex number, that iota square or I square is equals to -1, which is typically not possible unless you learn the complex number and something. We are just going to use the elementary part of the complex number. So let's use it in the simplest way. So let's say z is equals to, you just need to write complex and just mention the brackets, and let's write 2, 5, and again we need to print it because we want to see the result. So this time we need to write z because we want z to be printed. Okay, let's run it, and here it is, 2 plus 5j. Maybe they use I instead of j, but that's completely fine. This is how we represent a complex number. Those of you who have learned the complex number and about that, or even if you're going to learn about that, this is how it actually works. And this is how the complex number actually works and make the things happen in that part, where actually x-axis represents the real part and y-axis represents the complex part of it, and we can do the rest of the calculation like generalization, principal values, and complex analysis, and complex variables, addition, subtraction, multiplication, solution, simplification. We use that sometimes in the trigonometry, and the complex calculus and complex analysis is an entire new branch in the mathematics. Well, with all that said, I'm not going to bore you with the complex numbers. We are not learning complex number here, but I gave you a good idea that what are the complex numbers. Let me tell you something else. You can actually import in the Python the math thing. Well, let me put that in comment. So what we are actually going to do, we're going to import math. So what is actually meaning of importing maths? Well, you can use the mathematical tools, or I can say advanced mathematical tool actually, because in the first place when we are adding 2 plus 5 we do not needed any kind of the advanced mathematical tool, and you can hit enter and you can see that some error is showing that the C math is not defined here. Well, let me remove this one. Let's hit enter. So you can still see that import math is not defined here. Well, we can define that, and this is how you actually import that. We will try that again in later part, but for now I hope you have understood the complex number, that how it actually works. And let's try something else. Well, in the something else we are going to see how the float statement is actually going to work. So let's come up to the float. Well, what is a float? First of all, float is just the decimal, as I have explained you in the class. Okay, so float is just the decimal, and we are going to see something exciting. So let's turn integer into a floating number. Okay, that will going to be fun. So let's initialize it. X is equals to, now we have already created a space which can actually give us the answer. Okay, now X is equals to float, and what I'm going to do is I'm going to put an integer here. Like, let's say I'm going to put 99 here. So as we know that 99 is just a number and not a decimal number, so let's see if I added the float, what I'm going to get. Well, we do not get anything because we have not commanded it to print, obviously. So we need to print it up. See how smart the Python is. Till you ask it, it will never going to answer. Okay, so now it's 99.0. The 0.0 actually became because we used float here. Like, let me write it in this way. If I remove float just for a moment, removing those brackets, and now let's just print it. It's just a 99. So you can clearly see the difference, that what difference it makes when we actually make it float, use the brackets and write 99. Well, we are using the brackets repeatedly because it's a very simple point. We are telling Python that what's in the bracket apply the operation. So that's why we are using the brackets here. So this is our first thing that we have used. And now let's try something else. Let's try to put real number into floating number. Well, real number are just the numbers, the ordinary way of writing it, so it obviously includes the decimal too. So let's have a y as a variable this time, because we cannot use the x repeatedly. So y is equals to float, and let's use the number, let's say the value of pi, 3.1415926535. Well, I'm not going to bore you up with the values of the pi. So let's print up. There was a time when I actually remembered the value of the pi till 100 decimal places, but who cares? Okay, let's hit run. And you can see that it printed it exactly because the real number itself is the bigger part of the floating number. So floating number actually comes inside the real number technically. So that's why there is not much kind of a difference. And now let's try one final thing, which is let's try string, string, to float. Well, I have not told you about the strings in the very first place, so let me give you a glimpse about the string. We are going to cover that in data type obviously, but strings are just the alphabets, that's it. Like we have commanded in the very first place print hello world, so the hello world in the apostrophes that you put that in is actually the string. So let's just use z as a variable for now, and let's just keep the brackets and put the apostrophe, and let's write 3 point. Okay, let's try something different. Let's try the value of e. So it's 2.303. Okay, so what makes it different than actually the float? You can pause here and can think that what's the difference between the real number and the string? Well, the only difference you will able to get is actually the apostrophes, because that apostrophes are telling Python that this is not a natural kind of the number, this is actually a string, means alphabetical number. So in the alphabets we can use the numbers. So many times we used to do that in the daily life sometimes. So it's pretty much kind of the same thing, but anyway, it's just a string for the Python. Now let's try hit enter. Yeah, so we got our number 2.303. So Python again read the string as a floating point number. So this is how you convert integer into floating point number, real number into floating point number, strings to the floating point number, and all the kind of things that you can put and try that in so many possible ways. You can have fun and play with it as much as you want. Just for the sake of curiosity, I would like to teach you something more here. Like, what if I put x here and hit enter, or run actually? So you can clearly see that, okay, let me do this, x. Now let's try. So that's very interesting, right? Even this one, let's make it x and make it x again, hit run. But it's clearly making no difference, because all the x have their updated versions. We are putting the x, but actually in the Python there are the 3 different segments of the memory which is capturing that print information, or that it has to be printed. So why we used XYZ in the very first place? Well, that is good for the understanding wherever we are trying to do that, and obviously we are not fetching these results from one place to other. Otherwise the Python will surely get confused. Here we are not going to do so, so that's why it has understood it very well, and it's practically not making any difference. But if you are calling x, just x, in the whole program, just imagine what will it going to give you. Well, it will surely get confused that it should give you 99, 3.141592655, or 2.303. So it will get confused if we call it in some kind of a random situation, the complex kind of the programming. That's why we initialize different variable and different names so many times, so that it can actually be oriented for the object. I hope you have enjoyed this lesson, and we're going to see the next part of the dictionary in the next one. So till that time, take care, God bless, and see you in the next one. So we are on to our dictionary part. Well, what is a dictionary? Well, it's just a set of the organized information that is gathered through the data. Like, we can have the name, we can have the age, we can have any number and the address, maybe occupation. So these are the things that we are having, and this is the kind of the dictionary we are going to form. We are not going to form the dictionary of A for apple, B for ball, and that kind of thing. Well, you can create that one too, but we are not going to create that here. So this is the kind of the dictionary, the organized information out of the data that is gathered, and that is the dictionary itself. We are going to see that in the practical one. Welcome back everyone. Now we are on our dictionary part, so let's see that how we can create a dictionary. Well, we are not going to create an Oxford dictionary or Cambridge dictionary. We are just making the word dictionary. Let's name it, let's create a dictionary. It simply means we are organizing the information that we have grasped from the data in one part or the other. So let's write person. You can write anything as you want, and we are using curly braces here, and that single apostrophe I'm using it here, name, and we need to put the colon here, and then again let's write the name, let's write Udemy, let's put the comma, again the second information, let's say age, let's write 27, let's put the comma again, and let's use the final thing, which is let's say city, colon, and let's say the city is New York. So that's all what we needed. Well, in this part we actually do not need the colon,
because we are just putting the integer, and integer do not need apostrophes, right? You can clearly see that how the compiler actually helps us, because when I have kept the apostrophes, it's of yellow color, and when I remove that in 27, the color has actually changed. So this is how we get to know about the things. Okay, let's try to print this up, and let's print person. Well, believe me or not, but we have actually created the simple dictionary. And as you can see, there's a syntax error. Okay, so can you guess that why the syntax error is coming? I think it does. Okay, even after invalid syntax, we have got our result. Well, that's the beauty of the Python. It interprets everything, even there is a syntax error. So you can correct it later. Actually, that works. Well, when you're using any kind of the complex programming and you're actually having, just imagine how many errors we actually make. Don't think that no one makes the error. When you're writing a program of 10,000 lines, or sometimes thousands and thousands of the line, maybe it goes to the millions of lines together when we are working the teams and the entire organization is making a software and something like that. Actually, more than that, massive amount of data. Don't you think that there is a chance for the error? But Python is having our back, so what's the problem?
Now let's come to the Boolean. So what is the Boolean? Well, for the Boolean, I would like to change the color of my ink to red. Well, it can have just two values. As we have already seen, Boolean is nothing just 0 and 1. It's the binary. So it's a binary. Simple, right? So it can give you true or false. Well, in so many situations, it helps us. Like if something like this comes, it has to answer false, because 1 is not greater than 2. That's simple. So to simplify this and to sometimes efficiently and effectively coding, we use the Boolean. Well, you might be asking how. It's a powerful tool. Well, we can control the flow. Means we can decide that when a program has to be ended and when it has to be run. Like you have seen so many websites or softwares or so many places where it is written that plus 18 years only. So if you say yes, it will open. If you say no, it will not open. So this is what it's going to. Well, this is one of the possible cases. There are so many, but I think this is relatable. Okay.
Welcome back, everyone. Now we are going to work upon with the Boolean expressions that we are having. That's my cousin, please ignore him. So we are going to work with the Booleans. Okay. Now what the Boolean is doing here. So Boolean is actually zeros and one, the pair of the zeros and ones. Zeros are for the off and one are for the on. You can use it as for true and false kind of the values, and this is very powerful tool in using the entire kind of the work that we are going to do in the data types. So Boolean is going to tell us that the statement is true or false. Okay, so let's try something very simple. 1 is greater than 2. Okay, greater than 1, greater than 2. And also we need to initialize it with something like sx is equals to, and let's print x. So let's see that what it's going to show up. It's showing false. That's completely great, because 1 is not greater than 2, obviously. So it's printing the false. So as you can see, I have not used anything special. So Boolean is actually inbuilt data type that we can use without calling something, without creating something of that kind. Let's make it 10 just to learn that up and hit run. Now it's true because the statement is true, as we know.
Now we are onto our set. So what is a set? Well, unordered and unindexed data item written in the curly braces, that is the set. Well, you can call it as bundles also of similar kind of items. So bundle of items is also the set. Well, this is how we write the set. You can write it as it is, and you can see the results like this set: apple, blueberry, mango. These are the names of the fruits. And then if we print this set is this set, then the output is mango, apple, blueberry. Well, the order is not guaranteed, and that's what I have shown here. It is not ordered, like apple is in second place, blueberry is in the third place, and mango came in the very first place. So it actually changes the order. It might not, but mostly it do. So this is what the set is. You can't use the index to find the set. Well, if this itself is not defined that what is the position, so how we can call it with that? That's pretty much obvious, right? Okay, so how to call it and how to find that something is in set or not. So I've used the example here. You can see that print apple using the apostrophe in this set. Well, in is the Python reserved keyword, remember? So we are going to look into this set and check that apple is in the set or not. Well, as we know, it is in the set, so it will going to give us the output true. So hooray, we have just used the binary. So binary is powerful, right? It can tell you that it's there or not. Well, that's how the search engine works, pretty much kind of the similar way, that whatever you're trying to find, like if you're having a PDF and you're searching for a particular keyword, you can just type and it could just pop up. Instead of writing true or false, it will just pop up, and if it's not there, it will not going to pop up. It's that simple, right? Okay, now what are the operations of the set that we can use? Well, the very same dialogue that I'm using in the high school. If you have studied the maths, you definitely know about the set operations, but if not, don't worry, we are going to learn that. So the intersection of the set means something which is common in both the sets. This is the intersection. Like this is the A set and this is the B set. Let's say 1, 2 and 3 is the set A, and 2, 3 and 4 is the set B. And we find the intersection by writing a simple line of code. We are going to get an output which is 2, 3. So this is intersection. Now what is a union? Let's again take the example of A and B. Now the union means when we apply the operation, we are going to get the output from the union as 1, 2, 3 and 4. It means include everything, but the repetition in the set is not allowed. You cannot write 1, 1. You cannot write 2, 2. Like in case of school, it's written as like that. Well, I'm not mistaken in the spelling of the school itself. I know that it is SCHOOL, but double O is not considered and just single O is used. Well, you might be asking that what is the purpose of it? Well, you might have noticed that when you save a file, and let's name it XYZ, and now when I try to save another file with the name XYZ, it will show error. Well, by default it will going to add something like 1 or 2 and then save it, and else there is no option. So there can be only one copy of everything. So it assures that, because if we have multiple copies with the same name and when you call it, our machine will going to get confused that both are the same. Whom should I call? well, your machine can hang technically. So to save it, we use the different names. That's it. Now what is the difference? Well, difference is simply the subtraction, but subtraction is not in the simplest way. Here the subtraction means that we are having 1, 2 and 3 in the A set and 2, 3 and 4 in the B set. So if I have to find the difference between A and B, what I actually do is I just subtract the elements of B from the A. So the answer is actually 1. Well, that's pretty much interesting, but that's the reality. It just has to delete the items. That's it. Now it's about the semantic difference. So semantic difference is pretty much the same, and we're going to see that in the coding itself. So that is for the set operations. See you in the next one.
Okay, now we are going to work with the sets. So what is a set? A set is a collection of unordered indexed data items. Well, let's just start making the set, and then you're going to understand everything. That's what the set actually going to do and make the things happen on the ground. So let's just start making this. This set, let's say, let's name it this set is equals to, we are using curly braces for the sets, that's the rule. So now let's use the apostrophe. Let's write apple, and then let's write blueberry, and then let's write mango. Okay, so we have just created a set of the elements that is there. Now let's just write print and type this set. Okay, let's hit run. So as you can see, it's showing the pretty much way that we have done this here. But let me tell you something very interesting. Well, the order in the set is not sure. Well, it sometimes comes true, sometimes it not. So it is not going to index everything in the sequential way. Like the output could be like this. Let me show you. The output could be like this way. Like first can be mango, and then second can be apple, and then third can be blueberry. So the order of the set is actually not defined. Coincidentally, we are having the right order here. As you can see, when I hit the enter again and nothing changed here, like let's delete this up. I'm not doing any kind of magic, but the sequence actually changed up here. Let's run again and see. See, the sequence is getting changed as many as times I'm going to hit enter. So obviously you are going to get correct once. So this is how the set works. So the order is not defined in set and index one. Still, you can keep the information intact in this. And let's say that we want to do something more. Let's print here something. Print. Let's say we are printing apple in this set. So actually what we are doing and trying to do, let me tell you something that, let's write the comment for that first. We are checking that apple is the part of this set or not. So we are just checking that apple is a part of this set or not. We cannot do this simply out of like we can just go and see that all, because we are using just three information or three elements, I can say, in the set is called the element. Instead, if we are having 10,000 or 10 lakhs, oh my god, that's too much. And then we need to search something. I'm using particularly the word search. And you do not know that what can come, like it's in the first place or 10th place or 20th place, because you cannot output and you cannot read that. So the simplest thing that we use here is the in function that helps to check if the element is there or not. So let's hit run and let's see that what's going to pop up. True. So why the true came up? Well, the true came up because of this statement in the line number 6. So here's how the Boolean actually works. So it's the Boolean's beauty that is telling us the right answer, which is actually beautiful, because Boolean is telling us that how we can express the things up, and Boolean is actually working that way. Okay, now with all that said, let's try something new here. Let's delete the unnecessary comments that I have made here. Okay, that just makes it clean, nothing much. Okay, let's add something now. Let's try on adding something, and I'm keeping it blank. That will going to help us understand that we're going to add something. By the way, this is the comment itself, so I'm going to use the comment right here. And now just let's add something. So this set dot add, and let's use the brackets here. Let's add the grapes, and now let's just check that if the grapes is added or not. Print this set. Okay, let's see that it's added. Yeah, the grapes are added, and still the order isn't defined, so it's working good. Okay, now let's just try to remove something. So we have just removed the apple. Just write it simply and print this set, and let's hit run. As you can see, the apple is removed because of the statement number 13 and 14 that we have just printed. So we can remove, we can add to the new sets. Like your class is adding with a new student, we are going to add new and new students. And if something goes wrong and someone takes off their admission, we need to remove their data. So that's how that thing works. So I hope you have enjoyed making the sets, and we're going to meet in the next one to create something new and exciting. Till the time, take care, God bless, and sayonara. Welcome back, dear students, and now we are going to use some operations on the sets. So we are going to use some operations on our set. Well, if you have studied set theory in your junior high school or high school, you surely know about the operation of intersection, union, and all those kind of things. We are going to use that and apply that right here, right now. So let's just do that. And if even you have not done that, don't worry, we are going to learn it right here. So to apply the operations, first we need to create the set first of all. So let's create a set. Let's create a set with the simple numbers 1, 2, and 3. And now let's name it set 1 so that we do not get confused with that. Okay, let's write set 2 is equals to curly braces, and we are going to put let's say 3, 8, 2, 9. Okay. So we have created two sets, and now we're going to apply the intersection. So for the intersection, I'm just going to write intersection itself. So intersection is equals to set 1 dot intersection that we have applied, okay, with set 2. Okay, now let's just print intersection. Let's try to hit enter. As you can see, the result is 2, 3, because that's the only common thing, and intersection means the common part in set 1 and set 2, which is just 2 and the 3. So we have just got 2 and 3. This is how we use the intersection. It's so simple. Just write the intersection, right? Set 1 dot intersection of set 2. So this is the way we are going to write it. And even if I change the format here, like I write set 2 and set 1 here, in the intersection case, you are going to get the very same result. Let me show you here. See, we have got the same results because intersection means the common point. So common point from A to B or B to A, it's pretty much the same thing. Okay, with all that, let's apply the another one, which is union. Union is set 1 dot union bracket set 2, and now just print union. Union just basically is the totality, and let's see what we are having with the union. So as you can see, 1, 2, 3, 8, and 9. So it came in the readily sequence of the number, and surely the sequence is going to change as many as times you want. But here we are going to get 1, 2, 3, 8, and 9. So this is the totality of number, and the repetition is not allowed in the set theory. That is one important thing that you need to remember all the time, that set theory do not allow any kind of repetition. I'll show you that in the later part of it. Okay, let's just create difference. Well, difference is very simple to understand. Difference is just a difference. Means you are just eliminating something from one thing, like from the set 2 dot difference. Okay, difference bracket set 1 print difference. And always remember, we are not using any apostrophes when we writing print because we want Python to understand it, and we just do not want to simply just going to use it as a text and show it up. So maybe there's some spelling mistake at that. Let me see. Okay, here it is. Here is the spelling mistake that we are having. E-R-E-N-C-E. Okay, now I think it's fine. Yeah, it's fine now. So it's just 8 and 9. So we have just eliminated that. And in the difference, let me show you something special. If I change the set the way we have it in it from 1 to 2, we are going to get just 1 because 2 has eliminated from the set. So we are eliminating and not just simply subtracting. This is how the set theory works. Okay, let's have the one which is symmetric. So in the class I have told you that I'm going to teach you the symmetric one in the session of practical itself. So we are going to learn that right now. But I still think that you have got the idea of that how it's going to work, because it's just not very much different from the things, right? And sometimes what you think actually happens up. Now we need to print it up. So print symmetric difference. You can see how much time it saves when it pops up again and again. So let's hit run. And 189. So this is the symmetric difference. Means 1 is present in set 1 but not in set 2. 8 is present in set 2 but not in set 1. And 9 is present in set 2 and not in the set 1. So this is the symmetric difference. Well, we can just change it and let's see that what's going to happen here. 2 with the 1 and we are good to go. The result is pretty much the same because just like the intersection case, the symmetric difference we are finding, not the difference. Remember, difference shows a different thing, but the symmetric difference is going to differentiate the elements, which is in first element but not in the second one. So this kind of differentiating element, you can imagine that in the advanced level, when you are trying to program something, you want someone to access a particular part and you want not to get access, or someone not to get access of that particular things. So you can check it out here by the set theory, or the means of the set theory, that first what are the difference between the user and the creator itself. So this is how you can create that matrix in your work. Okay, so that's it for the set theory. I hope you have enjoyed the set theory a lot, and just like me, keep on practicing, keep on learning, and keep on growing. Sayonara.
Bye.
Now there are some reserved keywords that we cannot use as a variable, because if you can use everything as a variable, that will be more like XML instead of Python or other programming language. Something must be there for them also to understand that what is the meaning of what we are trying to create. So these are the 33 reserved keywords for the Python: and, break, def, else, finally, global, in, non, or return, while, as, class, del, except for, if, is, non-local, pass, to, with, assert, continue, else, if, false, from, import, lambda, not, raise, try, yield. Well, you do not need to cram at all. Just look at that carefully and analyze that. Most of the keywords are going to be used in our programming repeatedly, so that gets usual, and if not, and you see that, you have to recall this chart, 33 keywords exactly. Let's proceed. Welcome back everyone. Now we are going to see the basic operations in the Python. The first one is arithmetic, then we are going to proceed with assignment, comparison, logic, bitwise, membership, and identity. These are the 7 ones. 1, 2, 3, 4, 5, 6, 7. So there are just 7 operations that moves in the Python world. Let's see with the arithmetic, the very basic one. So here's the arithmetic operations: addition, subtraction, multiplication, division, modulus, which is actually the remainder, exponent, which is actually the power, and floor division, that rounds off to the integer. So this is all about the arithmetic. Like, let's say we have something like 2 plus 3 is equals to x, and we say print x. So the output is, as we know, is 5. So that's how in Python the arithmetic operators actually work. We are also going to see it's practical for all the operations, but for now let's move to the assignment one. So what is assignment operator? Well, it's simply assigning the things, like we are assigning x is equals to x plus 1, and we have already initialized x is equals to 2. So this is basically the assigning step or initialization, and then this is what addition, subtraction, multiplication, division, modulus, which is remainder, an exponent which is power, like 2 to the power 3 kind of thing, and floor division, that is basically going to round it off to for the integer. But that all will going to work with the assignment. That means the variable are involved and we are going to use it in this specific way. Kind of similar, that's why I have used both these together in the same slide. Well, I hope you have got this point, and now we are going to see it's practical. Let's come to the other operators. So the other operator is comparison and logic. Let's see the comparison first. Well, this is equal to. In the Python or in the programming languages, you do not write just one equal to show equal to, you have to write two equal tos, because the first equal to only means assign the value or initialize the value. So we need two equal tos to show that. This is not equal to, like 2 is not equal to 3. This is the simple maths, and this is the Python way of writing it. This is less than, more than, less than equal to, more than equal to. So that's pretty much it for the comparison. And now what's the logic? Logic deals with the and, or, and actually not. So these are the logic ones. Like and is the logical multiplication or is the logical addition, and not is the logical negation. So that's pretty much it. So and let's just see it for kind of the output. I'll just show you the output and input. Like let's say our machine is having 1 and 0 and 1 1, and let's say 0 1. So I've just used the three operations. These two are the inputs and this one is our output. So for the output, let's categorize into two parts. The first part is for the and the second part is for the or. The inputs are same. So if we are using the AND operation, it will going to be 0, 1 and 0, because these two when multiplied become 0, these two when multiplied becomes 1, and these two when multiplied becomes 0. Now in the OR, it's a logical addition. So 1 and 0 is actually 1. 1 and 1 is also 1. Don't count it for 2 because we are working with the binary. So in the binary world, there are just zeros and ones. So if both are open or on, that is on. And this is also going to be 1. Just for the sake of the curiosity, what if both are closed? Well, in the AND gate, it's 0, and in OR gate, it's still 0. Well, why I have not added the NOT gate? Well, because in NOT gate, we simply take one input and one output. So if it's 1, it's going to make it 0, and if it's 0, it's going to make it 1. So that's pretty much it.
So after that practical, I hope that you have enoughly excited about the Bitwise and membership. So what is Bitwise? Well, that is Bitwise AND or XOR, NOT, left shift, right shift. Well, these are pretty much it. And why do we use that? Well, we use that on the purpose defined by our own requirements. So as per the requirement, we use that. And now membership. Well, we have already used the in the set. If you remember, we have checked that Apple is in the this set or not. And not in means if it's not a member. Now finally the identity. So identity is going to tell us that it is identified in the particular element of the set or in the list or not, or in the particular statement. Well, we can use it multiple times, multiple ways and multiple things. So it is identified, and if it is not identified. Well, as I have said, Python is just English like. You have to add the logic for sure, but it's easy to grasp. If you understand the basics of the English and the basics of the logic, you can grasp it quite easily. So now let's see the practical for all these. What are Python flags? Well, this is the symbol of the flag. Well, there was a flag game, if you are old enough, in the desktop computers, and we used to play that and predict that where is the bomb and where is not. We just flag it up and then we get the points of those things. Well, that were the old days. Let's come to the new one. It gives the control for a specific segment or features in the code to the user. Well, it allows us to flag something, means we can even come back and have some changes, let's say, over there on that part of things. Well, that's basically what the flag means. Now we have used comments at so many places in our practical, but I decided to make it a separate slide too. And why here? Well, you will know that. So this is what we are using for single line comment, as it's mentioned, and we have used this one only multiple times. So why I have created a new slide? I have created a new slide because of this one. This is multi-line comment. Well, you might be asking that if we already have the single line comment, what is the use of the multi-line comment? Well, on the upgrade, sometimes we already write the programs and we just encode it as in the comment. You just have to remove it after some development or upgrade or something, and you are done. You are done with the new coding itself. So that's the multi-line comment. We write the codes and we pack the codes in these lines so that it do not get converted into the hardware specification for the outputs. Well, comment is technically means the understandable thing that we write actually, and it is not going to get interpreted or compiled, whatever you'd like to call it. It's pretty much the same in all the programming languages. We use it for our special purpose, but multi-line comment is used to stack the code and to release it later for the upgrades. And sometimes if it's vulnerable or self-destructive, we use it in that form. Well, if you're creating something rocket science kind of thing, you can try that out. Now, what is control flow in Python? Well, it refers to the order in which the statements and instructions in the Python is getting executed. That's the control flow. How much something has to run and when it has to stop. You have to decide it. And that's the way Python do it. So you actually have to fix the stairs. You actually have to fix up the things by using the logic. And the logic here is loops and the function calls. That's the condition that we are going to add. Let's see the conditions. So there are three types of control structure that we are having. First is sequential, second is selection, and third is the repetition. In the sequential, it's a default mode, and from the top to bottom something is going to execute line after line, everything one after another. So if you do not choose specifically something, it will going to be function like this one only. Okay, now what is a selection? Selection is if, else, and else if. We're going to see its detail and how it's working in the program itself. We are going to do its practical, but for now you can understand that if 2 is greater than 1, then print good. And if not, else print not good. Well, it's not working here, but it's close bracket, okay? Now, what is repetition? Repetition is basically for and while loop. While what is loop? Well, loop is continuously moving on and on in a circular form, and just the output is changing according to the condition that we give, and sometimes even that do not change if we command it so, and we're going to repeat the results again and again and again unless we set the condition to get out of that loop. So we use basically for loop and while loop to do so. It's very much interesting and kind of important at so many places where we do not need or we do not want to write so many lines for the same thing. We can just run the same logic for so many things and it will going to work out. Well, that's the repetition. We're going to see its practical execution in the program. So wait for that one. Now, welcome everyone again after the practical execution of the loops and the if-else programming on the conditional statements. I hope you have enjoyed it a lot, and now we are going to work on the function and modular programming. So there are built-in function, there are user-defined function, and there is autonomous function. So what is built-in function? Well, as the name suggests, it's built in. So we are not building it, it's built in. Like print is built in. That's why again and again in Python, whenever we are writing the print, it is giving us the output whatever it understood or whatever the logic of the code is telling it to. The length is actually telling us the length of the string and length of something that we are going to use. And ABS is actually the abstraction that we are going to see in the practical work. Okay, now now we are going to work upon the user-defined function. What is a user-defined function? Well, that's helpful in calculations like temperature calculation, perimeter calculation, area calculation, and actually so many calculation of the functions, and where we are using different kind of the stuffs. That is user-defined functions. Like I have to define a class, I have to define some kind of the specific particular data for a specific segment of the things. Well, that's all the functionality that you can imagine for the object-oriented programming is actually because of user-defined functions. A user can define according to their purpose that what the specific conditions are and when it should not work. So that's a user-defined functions. And what is autonomous function? That's basically the lambda expression. Well, we have seen the lambda so many times. Lambda is a mathematical part. Well, if you're enough curious, you can read about the lambda calculus too. That's coming in the mathematical part of the computer science. Kind of interesting thing, and you can use that for the specific purpose of data science
mostly, I guess. So let's proceed to the next one. It's a software design technique that emphasizes on separating computer programs independently, interchangeable modules. Well, that's basically what upgrades actually mean. They change the modules of the specific segment of the codes without actually reversing the codes or actually disturbing its original form. And it is also easier to develop and maintain the things. Welcome back everyone. Now we are going to learn about the advanced function concepts in our dearest Python. So let's develop our ninja skills. So what we are going to learn is kind of very advanced concepts, and we can use these advanced concepts in building the foundation to the very next level, and you have already surpassed the foundation level of the Python. So congratulations. First of all, there are decorators, then generators, then meta classes, context manager, and asynchronous programming. So as we are doing, we are first going through its theory and the basics. We are going to understand that, and then we are going to do its practical to learn something practically, and we can use it thoroughly throughout our programs. So let's begin. Here is our decorators, a function that takes another function as an argument and returns a new function that is decorator. Well, so what does it actually mean? A function that can take another function means it can carry more than one function. We can create the interdependence functions from this and can generate a completely new result out of it. It can add new functionalities and new functions without modifying original code. Well, let me give you an example for that. Like you have Windows Update, right? So like say we are having Windows 10. So on updating, we upgrade our Windows. Well, if not Windows, let's say Android or iOS device, we use these upgrades for the apps and for all the things. So what actually changes? App remains the same, it works the same, but its functionality differs. Maybe few of the functions are added, very rarely subtracted too, and modified, advanced for the better purpose. It's kind of keep on developing mode, and that's how the decorators actually work. It decorate the program more and more so that you can actually use the original code without modifying but still have the new functionality. It's like having a dashing car and modifying your car with the new wheels, with the new functionalities, rooftop. You can have the new features, you can have new lights, something like that. I hope you got my point and love my car too. Okay, that's the cartooning car. Okay, let's proceed to the generators. So what are the generators? Well, that is also a function that returns an iterator. Iterators are objects that can be used to iterate over a sequence of values. Iteration means going on and on and on. Something like propagation, you can say. So it propagates throughout the program to find the different kind of the result and pick it up. In the thousands, it pick up short list for us, and then we can actually get the result that we want or we are expecting. So generators are often called as lazy values. Well, why the lazy values? Because it only works when it is needed. Just like us, we only work when it is needed. We, the programmer, I mean, we work only when it is needed and where it is needed. We don't decorate and all that kind of things. that is the UX people do, and we have to fulfill that. So ultimately we get some work and we have to program the new things, right? Okay, let's proceed to the next one. Class that creates other classes. Well, that's why it is called meta. I hope you know about meta in a different way also. Like there are meta search engines that can find information from so many search engines. That kind is called as meta search engine or meta result sometimes. Well, we are too much dependent on the Google these days, but that's how it used to work when you use the metadata or meta classes. Okay, the second point is to add functionality without modifying the original code. Well, we are not modifying original code or something, but we are still adding up the new data. So that's a kind of thing like a parent is teaching or a teacher is teaching their students or kids some new skills. So they inherit few skills, but they also learn the new skills, and that is because of the meta classes. Now the very third point that we are having here is it automatically generate getters and setters. Well, these are important terms in the programming when we use the advanced programming, that we have actually reached to the level of the advanced programming. So we are going to learn that in the program itself. So for now, let's proceed. Well, it defines runtime context, means when the programming is running, it actually ensures, I have added double N to ensure the resources are properly cleaned up. So it's just a cleaning system, you can say. Your mom is always used to say that, close the door, baby. Okay, so that happens at my home quite often. Okay, a file which is open, so it ensures that the file is getting closed to once it is getting used. Well, here N is missing, I guess. Well, ignore the mistake. So what is open must have to be closed after it gets used. That's the context manager. Well, why it's important? Well, it's important because you want to log out, right? That's simple. Multiple tasks to run concurrently means together. It used to improve the performance of applications that needs to handle multiple concurrent requests. Like for example, right now I'm using the audio software, I'm using the PPT, I'm using the screen recorder, I'm using these three texts together to build this class. So that actually working concurrently means at the same time on the runtime, and it's increasing the performance of the application. Well, we are not building the application here, but let's say it's increasing the application. Well, in some cases, like if you're having a good tower, you can work with the WhatsApp that's connected with your photo gallery and videos and all that kind of thing. So it can fetch out the result, and wherever it's required, it's going to use that, and we are going to work on that specifically. So, oops. Okay. So this is all about the asynchronous programming. Now it's the OOPS, means object-oriented programming. So what is object-oriented programming? That we have discussed already. So it's a paradigm that uses object to design application and the computer program. Well, for the specific need, obviously we have discussed this already. Now let's discuss that what are the objects that we are repeating again and again. Objects are actually the data structure that we have studied extensively, like a numeric dictionary and all that, consisting of the data fields and methods together with their interaction. like we also need to interact it with our compiler or interpreter, whatever we're using, so that it can actually give us the right kind of the output. Like you cannot use the same compiler for all the programming languages for sure. So that's how a specific object is using a specific kind of circuit in the digital electronics and the real electronics. It's going to fetch up the result. Like if I say 2 plus 3, so it will going to activate this positive sign, the addition circuit, and that circuit is going to work here. So that is a kind of object. Well, technically operator, but you can relate that. Okay, now the third point is, it makes it easier to create complex programs that are easy to maintain and reuse. Then write program for once and reuse it all over again and again and again. That's what all the efficient programmers do, and you must do it too. So why you're learning the same concurrent things, and why not you are generating the things out of the AI like Gemini, or which was previously called as Bard, and ChatGPT or something like that? Well, in my opinion, you can take that. That's an advantageous thing. But if you know how to modify that, how that actually is working, you can be more and more efficient. Yes, that can generate so many things for you. And if you know how to manipulate that, if you know how it's working, so you can make your own things in your own way, not a copy of something. Okay, with that, in Python is based upon the 4 fundamentals: classes, objects, inheritance, and polymorphism, and our cutie pie snake. Here it is. Okay, so what is classes? Well, it is used to create objects. It's like a blueprint that we prepare to create the object, and it defines the properties and behavior of the object that will create it from it. Like if you create a class, let's say animal, so you are defining everything about the animal itself. Well, we are going to use this in programming itself, but for now you can imagine that we are going to talk about the animal. That is user defined, obviously, and that is the function of the class. We can have so many classes in the complex programming, and that's amazing actually, because when we use so many kind of the classes, we can classify so many things. We can interact in our one program and create a very complex kind of program with its own different features. And why it is called a blueprint? Well, by reading all the classes, you actually know that what are the possibilities that particular program or application can actually do. So that's what a programmer do. Now back to the objects. Objects are instances of class. Like our object was animal there. They created by calling class like a function. Well, you can call a function again and again. Once you write a program, you can use it anywhere, wherever you want. Like you have created something in line 1, you can call it in line 1000 or 10,000. That depends. You just have to call that function. Hey, are you hearing me? You are needed here. Come up, and it pops up here. So write once, use more. That's it. Let's proceed. Inheritance. Well, if you have studied the science, that definitely all of us have, that's the actually inheritance means. Inheritance means you get the qualities of your parents as first generation and pass it over to the second generation, and then third generation, and so on. So that's pretty much what inheritance actually means in the biology. So the very same thing happens in the Python too. It allows to create new classes based on existing classes, allows to reuse code and create complex programs. Like if you learned to walk, now you can run. If you learned to run, you can run on treadmill. by maintaining your balance. If you learn to balance, you can walk on the rope. Well, that's too much. Okay, so that is the kind of inheritance. Like every skill is built upon the fundamentals that's underlying it. Like you are learning this course, and this course is going to elevate you from here to here, like from beginner to a ninja. Now, what a ninja should do? A ninja should keep on moving and learning in the forward direction, polishing their skills, right? So, that's what is called the perfection. So, work to be perfect, but that is what the inheritance. This course will going to give you the inheritance trait of learning to the advanced programming concepts and your own projects. So many places and so many fairs. Okay, what is polymorphism? It allows us to write code that can work with different types of objects. This makes code more flexible and usable. Well, word poly itself, if you are family in the mathematics, so it's actually used for 4 or more, like polynomial, I could say. In science, at various places, the poly word also used, like polythene, polyethene. That means more than 4 chains. Now it's polymorphism, like morphism is the word, and we are adding the poly, which means we can use multiple morphism. Morphism is actually the different types of the codes or the block of the codes that we can use it again and again for the functionality. Like we have created the class animal, so obviously all the animals have something in common, like they live on earth, and as much as I know in the biology, they intake oxygen and they outtake carbon dioxide. They all need food and water to survive, and they need a climate where they can live. Well, that's the earth technically. So that is the polymorphism actually. If you create one, you can use it for all kind of the species. Maybe the variety of the food must be different, right? Okay, so that's it for this one. Now we are on the advanced oops. So let's make some eyes. Yeah, now it's watching us. And 3 eyebrows, that's enough. 1 cute nose and 1 smiley face. Now it looks perfect, right? Okay, so first of all, there is encapsulation. What is encapsulation? Well, it is bundle. Bundle of what? Bundle of code. So we encapsulate the code, or you can call it simply packaging of code. You are just packaging the code, and you can use it multiple times at multiple places just by calling them. That's what we have learned in the oops part. Now advanced oops works on pretty much the same thing. So it can be accessed or modified intended ways. Well, we can protect it basically, like if we have MS Excel, or let's say we have spreadsheet for simple, or sheets. Well, they pretty much have few things in very common, like they have the rows and the columns, the file that we need to save as, create new, old, and that kind of the functions and other kind of things too. So what is encapsulation mean here? Means its basic fundamentals are protected from unintended ways. Like I cannot just go the very next day to the sheets and I open the Google Sheets and delete the save option, and no one can ever save their file. I cannot do that. Why? Because it's encapsulated code. I think you get the idea of it. Now it's about abstraction. Remember that ABS thing that we have studied in the function? Here it is. Abstraction. Abstraction actually helps to hide the things and implementation of the data from the user. Well, we can hide, but why should we hide something? Well, not everything is front end. Something has to be back end, like security. So you have to hide it. So you need abstraction and encapsulation. These are the advanced OOP concepts, and usually they used when you are writing some advanced kind of softwares, or you technically need that for some specific reasons where you do not want someone to access. Basically, whenever something is released in public, it's not open source, it's private, it's almost encapsulated and with the abstractions. So you cannot touch that thing. That makes code easy to understand. Well, maybe you are not seeing the entire code itself, so it's easy, obviously. So that's about the advanced OOPs. So that's it for this section. I hope you have enjoyed it and you have learned something new. So see you in the next one. Take care. Welcome to this new section. This is file handling. Well, the most important thing in the old days is to handle the physical files, and in the digital world we have the digital files. So files remains the same, you have to keep that. So what is a file? That actually keeps the data. That's it. Out of which you can do so many things like manipulate. Okay, so you need to learn to handle the files well. Like previous days, they have the sections and the corners for the specific files and the specific color for specific things. Like if you are in school, you are still facing that. Like the biology notebook must be blue color or that color, this color. This kind of silly things happen, but not so silly. Okay, so that is kind of file handling used by our school, obviously. I never found it useful because I can just stick a big sticker that yes, it's biology, so what? Okay. Okay, so file handling is actually very important part of any programming language, not just for the Python, but all the programming languages if you have learned or if you will going to learn in the future. It allows us to read and write data in the files, which is used to store data for interacting with other programs. Well, the last line actually changes everything. We can interact with the other programs by using the file. Like I told you, I am recording the audio. So my audio file must have to interact with my PPT, and my PPT has to interact with the screen recording. All three things has to interact with each other, only then I can make this course. So that's called interaction of one program to the other. All the programs are in different formats and I have to merge them to make it a single one to get a definite output. So that is the kind of file handling I'm doing right now. So important functions in file handling is actually just the one. You first have to open it, right? Well, I think the closing of file is not mentioned. Let me mention it here. So to close the file, we use this. Remember, closing a file is very important, like logging out is important. That we don't do these days in our iPhones and even in our Android phones. So many of the apps are actually accessing everything in open mode and we are saying that we are unsafe. That's a big question mark and the snake is laughing on us. Okay, so what are the modes of the file? Well, R is for read, W is for write, A is for append. What is append? Append means adding up the new thing to the list. Okay, what is R plus? R plus is reading and writing itself. So these are the ways a file can be handled in the very initial phase, I can say, or they are just two arguments that we need to open up the file, which is the name of the file and the mode we want to open in it. So we first open by putting the name, like my file name is let's say best, and the mode I want to open it is let's say read. So this is something, well, very elementary way of representing it, but I hope you get the idea. So that's how it's important to handle a file, and this is how you actually handle it up. Right, Snakey? Well, right. Okay. Now, what is exception handling? Well, the process of responding and recovering from error that occur during program execution. That is exception handling. Well, the exception in your life as a programmer comes very often, like in the chemistry people, exception comes very often. Like this is exception, that is exception, because of this, because of that, and so on. So chemistry and programmers actually handle the exceptions. Okay. So this helps us to prevent the program from crashing and allows to continue running even when something goes wrong. Well, if we do not just imagine a world for a moment which is not having exception handling techniques. So if something crashes on the internet, everything on the internet going to crash. Well, that don't happen. It goes well. Like, let me give you an example. When the 2000 era came, so people used to say that when it will going from 1999 to 2000, the computers are going to get crashed because the year is going to change, the century is going to change, but actually nothing happened. Obviously, the people are learning the basic maths, and we are talking about the geniuses in the programming and in the computer science world, the computer scientists, engineers, and every kind of people. They know the simple maths. You just have to implement the numbers right way. So nothing actually happened, and we are talking about this thing in 2024. So it's working good, right? So that's how your exception handling happens. Well, there are two main ways to handle the exception in the Python itself, specifically, that is try and accept, or you can also raise the statement. Well, so why I've written just two, because try and accept used in once generally. So obviously raise is the second one. Okay, so try and accept statement are used to catch and handle. Well, that's important word. It catches and handles the exception. First of all, you need to catch the culprit, that what is bothering you, and then you need to handle that very well. The statement contains code that may raise an exception. An accept statement contains the code that will going to execute if the exception is occur. So we always keep the backup plan. If you have a good backup plan for the emergency situation, you never run out of the ideas actually. So this is the way, these are the two ways actually to handle the exception. First you need to catch it, then you need to handle it, and in the meantime you have to run something which is actually working smooth on the ground. So that's why internet seems so smooth, but if you are the creator yourself, you will actually find it so many things that you actually are handling on the back end, so that the front end people can say how easy it is. That is so smooth, right? So you are responsible to make the things smooth. Buckle up, buddy. So finally, let's talk about the best practices that we can have. Well, always catch exception that you know how to handle and let the rest to propagate up. You do not want to mess up the entire program. Always remember this thing. A good programmer never messes up the entire program, but surely catches the flaw part. Second point is, use the most specific exception possible in your except clauses. Well, if you are not specific about your exception or the problem or the scenario or the situation, so you are actually messing up with so many files because they all are interrelated. As we have talked about the polymorphism and inheritance, everything is getting connected at so many places. You are calling the function and doing other things, so you have to change it at so many places. So believe me, you don't want to do that. That's why be specific. The third point is, avoid catching the base exception class, as this can mask real issues in your code. Well, if you are changing the animal itself in the class, so how can you put the animals? That's an example of it. So just don't mess with the base of it. Okay, now finally, blocks clean up resources even if an exception occurs. So use finally blocks to clean up. We should always clean it up. Like we clean up the cache memory most of the times in our devices so that we can have the smooth transaction of the files in the technical words, but simply we can use it smoothly. So just clean it up time to time. These are the best practices. So I hope you have enjoyed this and see you in the next one.